All right, and welcome. Today we're talking about lesson 1-3 line segments. And again, this video is intended to supplement classroom instruction for those students who weren't there, those students who need a little bit of different additional help with the material that we're covering in class. So as we talked about line segments, some things we're going to talk about calculating measurements. We're going to talk about applying the definition of congruent lines. Congruent will be a new term for us this section. Here's our key vocabulary that we're going to talk about. So beginning, let's see here, betweenness of points. A line segment is a measurable part of a line that consists of 2 points. We have endpoints, okay? So all of the points between them, the 2 endpoints, are used to name those segments. So if we learned last section, line AB right here, this would be a line because we have arrows going in both directions forever and ever. We could write it as line AB. What they're saying here is we have segments now, and segments are just going to have endpoints. So if we wanted to write segment AB, it would be AB with just a straight line over it, indicating basically that we have the ending points. It does not go on forever and ever. So that is a line segment. Understanding betweenness. The way this is written here, this concept of betweenness, they're basically saying in this, it says, point C is between A and B if and only if A, B, and C are collinear. So A, B, and they said C is between A, B. So if they were collinear, that means they all are on that same line. And then therefore, AC plus BC equals AB. Big concept here. We're going to do a lot of this stuff, but AC plus CB is going to be equal to the entire length of AB. And that's it. We don't know what those lengths are, but we know by definition of betweenness that those two, that is a accurate statement. I like to refer to this as my definition or my definition, because this is going to be the formula that we're going to use and we're going to fill it in. All right, so let's see here. Finding the measures of XZ in this example number 1. Okay, so XZ, we can see in our image, we have XYZ, they appear to be collinear. So if they're collinear, then I should know that XY plus YZ should be equal to the entire length of XZ, and that's what they said. So again, XZ is a measure, Y is between X and Z. Find XZ by adding, right? We're just going to sum those two things together. Betweenness, XY plus YZ is equal to XZ. Fill in the blanks, and we come up with, or we do the substitution, not just fill in the blanks. But let's see here. This would be 11.3 plus 3.8. I'm hoping that is 15.1. I hope. So there you go. That would be the entire length, adding those two lengths together. Here, finding the measure of DF. Okay, so in this check, I wrote some stuff over here for you. Hey, remember, some students will want to convert these into decimals. If you're having difficulty with fractions. Let's see here, convert fractions to decimals. So just input into the calculator. Here, this would be 7 divided by 10 and hit enter, and it should give you a 0.79 divided by 10 and hit enter should give you a 0.9. Listen, some of my students just do that. They have to work with the decimals. So this would be 2.7, this would be 5.9. So find the measurement of DF. I know that DE plus EF is equal to DF. I will continue to write these formulas down, this definition, because when it gets more difficult, it is something that I can simply fill in and solve. So DE is 2.7 plus 5.9 is equal to, let's see here, that should be hopefully 8.6, right? So there is 8.6. Fast forward, fractions real quick. And then there you go. There's my fractions real quick. Feel free to stop the video, but hey, I have like bases. I combine the numerators, or like denominators, I combine the numerators, simplify. So moving on here into finding the measurements by subtracting. Again, just using that definition of betweenness. If Q is between P and R, Q is between P and R, therefore I know PQ plus QR is equal to PR. All I have to do now is substitute and simplify. So with that, let's see, I'm going to have PQ. PQ is 6 5/8 plus QR. I don't know what QR is yet. That's what I'm trying to find out. But I do know the entire length of PR is 13 3/4. All right, so I went ahead and just converted it to a fraction real quick in case that's what you needed. So this is 6.625 plus QR is equal to 13.75. Subtracting, oops, a little typo here. Subtracting 6.625 from both sides because I'm trying to get QR by itself. Turns out that QR is going to be equal to 7.125 or 7 1/8 because that's what they did here. They just subtracted 6 5/8 from both sides because they were trying to isolate their unknown value, and then that's what we get. So here is my 7.125 or 7 1/8. Now, going on to this next check, take a second, do it on your own. I'm about to fill it out, but that's what we're doing here is we're just using our definition and solving. So to begin this, find the measure of PQ. Round your answer to the nearest tenth if necessary. We can see that we have a segment, so I should know that by definition, PQ plus QR is equal to PR. I don't know what PQ is, but I know that QR is 17.8, and I know that PR is 24.3. So to find what the value of PQ is, I subtract 17.8 from both sides, and I understand now that PQ is going to be 6.5. So 6.5 centimeters. It says round to the nearest tenth. It is at the 10th value, so there you go. I will tell you too, I took a moment, I typed it into the calculator to get this answer because I do hate when I make simple mistakes on videos. So there you go. Let me see. I'm going to go ahead and skip over here in our notes. This is a problem that I pulled from our class assignment as a different example. I guess I'll wait until after we do this example. Okay, so write and solve the equation to find the measurements. So we're going to use that same definition of what was going on. So in this example, we're starting with a little bit of algebra, but the premise is still the same. So it says find the value of x and BC. Okay, so we have to find two things, x and BC, if B is between AC. Okay, so there's our betweenness. So A, B, C, they said B is between AC. And then they just started labeling things. What do we know? We know that AC, the entire length, is equal to the two little pieces put together. And then we filled in what we were given. They said AC is 4x minus 12. AC is 4x minus 12. AB is x. X. So AB is x. And then BC is 2x plus 3. 2x plus 3. BC is 2x plus 3. So I know then that 4x minus 12 is equal to x plus 2x plus 3. They combine some like terms here. So 4x minus 12 is equal to 3x plus 3. They went ahead and did some inverse operations. It looks like they went ahead and subtracted 3x from both sides. So we ended up with just x minus 12 is equal to 3. Then they added 12 to both sides. And then x is equal to 15. And that was the first part of the problem that they asked us to find. Then the second part of the problem they asked us to find was BC. So BC was the equivalent of 2x plus 3. They substituted in 15 for x. So 2 times 15 is 30. 30 plus 3 is 33. So there you go. We were able to find both values walking through that example number 3. That is reason I brought problem number 10 over here from our classroom assignment today, just to give us an example. So take a moment. It says to find the value of x and yz if y is between x and z. So I'm going to give you a moment, and once you're done, check your answer. And then here I go. So if x, y, z, they said y is between xz, I know that xy plus yz is equal to xz. Good starting point. Substitute in my values. xy is 11, yz is 4c, and then that is equal to the entire length of xz, which is 83. Inverse operations, isolate your variable. So I'm trying to get minus 11 from both sides. That becomes 0. 4c is going to be equal to 72. I'm going to divide both sides by the coefficient. And then c is going to be equal to, c should be equal to 18. Okay. Then substitute, because it's trying to find out what is the value of x. I think here they meant c. So we found the value of x slash c. That's my unknown value. And then what is the value of yz? Yz was 4c, so, well, 4c is equal to 4 times 18, or simply 72. Okay, so there's an example. All right, moving on. And I'll just say we're going to apply some of the things that we've done here in example number 4 and the use of betweenness. Gosh, a lot of words here, a lot of stuff going on. But the Space Needle. If I were to skip down and figure out, hey, what in the heck is going on? It says, help Daryl find the distance from the ground to the observation deck of the Space Needle. So let's just talk about it. I may not do these in exact order, but so Daryl is visiting the Space Needle in Seattle. He knows that the total height of the Space Needle is 605 feet. So in this diagram, I went ahead and labeled 605 feet is going to be the total height. The distance from the ground to the observation deck is 10 feet more than 6 times the distance from the observation deck to the top of the Space Needle. Whew. Okay. The thing with word problems and examples often is, what did they not tell us? In this example, they did not tell us what this distance is from the observation deck to the top of the Space Needle. But then they turn around and said, well, the distance from the observation deck to the ground, right here is observation deck. Ground to the observation deck is 10 more. So 10 plus 6 times the distance from the observation deck to the top. Okay? So that is the unknown value. So we just sort of said, hey, I guess that's x. I don't know what it is, so I'm going to call it x. Therefore, I sort of identified then that top part is x. So this should be 6x plus 10. I just sort of moved it around. Those are the things that I'm thinking about. Betweenness, I should know that the concept of betweenness is that from the top to the bottom, the observation deck would have to be between those 2 points. It's not sitting over here out of the way. So I'm able to apply those principles. So let's see, did I miss anything? Describe the task in your own words. I'm trying to figure out the portion. Then list any questions that you may have. Again, the question is that unknown value that they didn't give me. That was one of the first things I thought of. Another thing that we made some assumptions that we had the betweenness going on. how will you approach the task? What have you learned that you can use to help you complete the task? We know that, the two little pieces add up to the total piece. What is the solution? So what equation represents the distance from the ground to the top of the Space Needle? From the ground to the top of the Space Needle? Well, if I took all of that and added it together, the total amount should be 6x plus 10 plus x, right? That would be, or I could say 7x plus 10 by combining like terms. What is the distance from the ground to the observation deck? From the ground to the observation deck. I haven't figured that out yet because I haven't solved for x. But I do know that these two should be equal to 605, the entire length. If I go ahead and do my solving for combining like terms and solving for x, I have 7x is going to be equal to 595. Divide both sides by 7, and then x is going to be equal to 85. 85. So the portion from the observation deck to the top, this portion right here is 85. So the distance from the ground to the observation deck would be 6 times 85 plus 10 is equal to my missing value. There you go. So with that, that should cover much of what we've talked about today. And then here, the next part is line congruence. Congruent means things are equal, means they're the same. Congruent segments. If use a consecutive number of ticks. So congruent segments, the way that you indicate congruency is that we have a little hash mark here, a little tick. So anything in this image, if I have two things that, let's see, it should have extended here with a photocopy that. I dragged that picture out of the book incorrectly. I know that anything with one tick should all be the same length. If I have more than one congruent item in an image, then these two would be congruent to each other because they both have 2 ticks. And then these two would be congruent to each other because they both have 3 ticks. If I were to draw something else over here, we'll call it ZY. And I put one hash mark on there, one tick, then that means that it is also congruent to these. If I were to have drawn 2 ticks, that means that it may not look the same length, but technically it is the same length because it's on the same image with the same congruency indications. So that's how we show more than multiple congruent items, or so that's what we're talking about here. So congruent segments. This symbol right here is how we indicate congruency. It looks like a little equal sign with a little squiggly over it. As one student said, it's a squiggly equal. If that's what helps them, absolutely, that's what helps them. So to draw a congruency symbol, looks like that. And then if I see these things, if I see a congruency symbol, this tick, these two things should be congruent because they are indicated the same way in geometry. And I look at the length, 1.7 centimeters, 1.7 centimeters. So I know that a segment AB is congruent to segment CD. And of course, if I have congruent segments, that means we have the same measure. So we will often see this written. We will understand that this is indicating, the measure of AB is going to be equal to, that looks very poor there. Let's just do the measure of AB is equal to the measure of CD. And that's what we understand when items are congruent, their measurements are the same. We'll deal with a lot of congruent things in this class, so just understanding that. So write and solve these equations here in this example. They've told us some information, things that we can probably look at right here, that I should see this little tick mark. That means that PQ is equal to QR. Well, that is my definition. If things are congruent, they are equal. So PQ is equal to QR. And then it says find the value of X if Q is between PR. So there's my betweenness. So some things I know that PQ plus QR is equal to PR. But in this case, it's easy enough to understand congruency and just say, hey, PQ equals QR. And that's what they did. They did some substitution here. So they took and they substituted in for PQ, they substituted in for QR, and then they continued to solve the equation. It looks like we ended up going from here to here. They did the distributive property, right? 2 times x is 2x, 2 times 6 is 12. Then they turned around and let's see, what did they go? Then they turned around and said, well, let's subtract 2x from both sides, right? Because I'm trying to combine like terms. 2x minus 2x became 0. Sorry, let me see here. I did distribution property. So when they simplified, also known as combining like terms, they got 4x plus 20 is equal to 12. Then again, they're subtracting 20 from both sides because this becomes 0. So 4x is equal to negative 8, dividing both sides by the coefficient, and then x is equal to negative 2. So there is what we have. We have solved that using some of those guiding principles. So with that, the example we're going to do in class, or this check, is find the value of x if u is between TV. And I went ahead and included this here for you because I love an image. So U is between TV, and then I just fill in the blanks. What do I know? I know that TU plus UV. Oh, I don't even need to worry about that. Right there, they told me that TU, I know that for betweenness, but they told me that TU is equal to UV when they told me that it was congruent. Let's see here. So TU is equal to 7x plus 35. UV is equal to 4 times x plus 7. And then I just make those things equal to each other and solve. Let's see here. So I have 7x plus 35 is equal to 4 times x plus 7. 7x plus 35 is equal to, I'm going to do my distributive property, 4x plus 28. Start combining like terms, right? Subtracting 4x from both sides because I want to get my variables together. I have 3x plus 35 is equal to 28. Whoa. And then I want to get my numbers together. So I'm going to subtract 35 from both sides. And then I end up with 3x is equal to negative, how dare they, negative 5, negative 7. Divide both sides by the coefficient of 3. Turns out that x is equal to negative 7/3. Let's plug it back in and check it. Let's see here. So I get 7 times negative 7/3 plus 35 is equal to 4 times negative 7/3 plus 7. And it turns out that we have 18 and 2/3 is equal to 18 and 2/3, or some of you, if you use the calculator, you would have seen something like 18.66667 and would be equal to 18.66667. Right, so there you go. That is using those examples. So we'll continue on with our lesson today. Again, this is intended just to supplement our classroom instruction.